Right, what happens when we have a power of a power? In this case, x to the power of 5, and all of that is the power of 3. Well, what does the power of 3 mean? It means the thing inside the brackets times itself 3 times. So if we write out the long way, now we have a question similar to what we've done earlier. When you multiply, you just add the powers. So a shortcut would be just say 3 lots of 5. 15. So 15 is our answer here. So the rule is going to be if you have a power on the outside of the brackets and a power on the inside of the brackets, all you have to do is multiply those two powers together. So here's an example. G to the power of 7, all of that to the power of 4. Just using our rule, we have to multiply 7 times 4, and that's going to give us G to the power of 28. Let's do a further example, but this time we'll put the coefficient, the number 4, inside the bracket. So all of this to the power of 3. All you have to do is apply the power to each bit inside. So 4 to the power of 3, and y to the power of 5 to the power of 3. 4 to the power of 3 is 64, and we just have to multiply those powers, y to the power of 15. This time, slightly different, we'll keep the 4 outside the bracket, and this time the power of 3, because of BEDMAS, only applies to the y to the power of 5. So these do not give the same answer, just a side note there. What if we have a fraction? Let's try this. Negative 2 over 3 times x to the power of 3, y, and then a decimal power. Well, if we just apply it one thing at a time, let's just look at negative 2 over 3 to the power of 3. What does that mean? It means negative 2 to the power of 3 over 3 to the power of 3. Negative 2 to the power of 3 is going to give us, negative 8 over 27. Now we just have to apply the powers one at a time using that same rule where we multiply the powers. Y to the power of 1 times 3 is 3, and z to the power of 0.5 times 3, 0.5 times 3 is 1.5.